Today we're going to look at how to write equations from roots. So we're going to write quadratic functions given the zeros, given the leading coefficient, and or given another point. We're also going to write the functions given a graph or a chart. First thing we want to look at in this example where x equals 3 and x equals negative 2 is what factors are going to give us x equals 3 and x equals negative 2 if we were to set them equal to 0. So if I had something in parentheses equals 0, and I want to end up with x equals 3, what is going to make me solve it to get x equals 3? Well, if I have x minus 3 equals 0, if I add 3 to both sides, I end up with x equals 3. So what we're doing is we're basically using the opposite sign. So if we're given x equals 3, x minus 3 is going to be our factor. Since when we solve it and set it equal to 0, we have to do the opposite operation to bring it to the other side. So if we had x minus 3 as our factor, you have to add it to get a positive 3 on the other side. So we know we're using x minus 3. And if I have x equals negative 2, what's going to make that equal 0? Opposite sign, so x plus 2. Okay, so if I solve these, let's double check. X minus 3 equals 0. X is going to equal positive 3. X plus 2 equals 0. X is going to equal negative 2. Okay, so it's the opposite sign. If we look at the next example, okay, if I have x equals 4/3 and x equals 1, we can think of it this way. So it's a positive 4/3. So we can say x minus 4/3. But we're not used to seeing things like this. We don't usually see fractions within our binomials. So what we can do to get rid of that is multiply by the denominator. So the denominator is 3. I'm going to multiply by 3 on the outside, and I'm going to distribute. So what happens now is I have 3x minus 4. Okay, so that's going to end up being 12 over 3, which is 4. This is something that we're used to seeing. If I set this to 0, I add 4. 3x equals 4, divided by 3. X equals 4/3. So instead of keeping it as x minus 4/3 in the beginning, I distribute that 3 into it. So we're going to have 3x minus 4 as a factor. And then if x equals 1, we're going to have x minus 1. Okay, so we want to write a quadratic function. So what we have right now is we have our two factors. Okay, so I'm just going to get rid of this for the moment. So now all we need to do is FOIL it. So for the first example, I'm going to have f of x equals, and I'm going to FOIL. I have x squared plus 2x minus 3x, so minus x, minus 6. So here is the quadratic function that has those given zeros. Same thing on the other side, we're going to FOIL this. So f of x equals 3x squared minus 3x minus 4x, so minus 7x plus 4. Okay, and there's our quadratic function. Okay, so let's look at another one. So here, we want to write a quadratic function given the zeros and the leading coefficient. So if x equals negative 6, I know that the factor that's going to give me that is going to be x plus 6. It's the opposite sign. If I have x equals 2, I'm going to have what? X minus 2. Okay, so let's FOIL this together. So we're going to end up with x squared minus 2x plus 6x. So that's minus positive 4x. And then minus 12. But it tells us that there's a leading coefficient of 3. So that means there has to be a 3 in front of the entire function that we need to distribute in. So our final answer for this is going to be f of x equals 3x squared plus 12x minus 36. It's very important that you guys put the f of x in front. So whether you want to put f of x or g of x or y, okay, it doesn't matter, but you have to have something equals the function. You can't just have the function. Okay, so let's look at the next example. X equals negative a half. So again, opposite sign. So we're going to have x plus 1/2. But remember, we don't want to have fractions in our problem. So we need to multiply by the denominator to get rid of it. So our denominator here is 2. So I'm going to multiply by 2. So I'm going to end up with 2x plus 1. If I have x equals negative 4, that factor is going to be x plus 4. So we're going to FOIL this out. So we end up with 2x squared plus 8x plus 1x, so plus 9x plus 4. And again, there's a leading coefficient of negative 2. So we're going to tack on a negative 2 in the front, and we're going to distribute. So f of x is equal to negative 4x squared minus 18x minus 8. And there's our function. Okay, so let's look at a problem where we have a graph. Okay, so we're given the graph. What we want to do is we want to find our x-intercepts. So looking at the graph, I can tell that an x-intercept is going to be here. So that's x equals negative 2. And also here. So x equals 5. So I can use that information and I can set up my factors. So I'm going to have x plus 2 and x minus 5. And I'm going to FOIL this out. So x squared plus minus 5x plus 2x. So that's plus 3x. And then minus 10. So we need to figure out whether or not there's a leading coefficient. Okay, so in the previous examples, like on these, they told us there was a leading coefficient. Okay, if you're given a problem like this where it says like x equals negative 6 and x equals 2, and they don't tell you there's a leading coefficient, you're assuming it's 1. If they give you a graph, you have to use the point that they give you in order to figure out what your a value is. So what we're going to do is we're going to set this up and we're going to say y equals a times x squared plus 3x minus 10. Okay, so a is our leading coefficient. We're trying to find what that is. So we're setting the function equal to a times whatever we had over here. So now I know a point. I know this point for negative 6. So I'm going to plug that in for x and for y. So I'm going to say negative 6 equals, and a is going to say a. So now I have 4 squared plus 3 times 4 minus 10. So I end up with negative 6 equals a times negative 6. And then I solve for a. When I solve for a, I get that a equals 1. Since a equals 1, my leading coefficient here is just a 1. So I don't have to multiply everything by any number since it's going to stay the same. So my final answer is x squared plus 3x minus 10. Okay, so let's look at one that's a little bit different. So same idea here. Okay, we're going to first find the x-intercepts. So I have one here at negative 4, and I have x equals 0. So I know that my factor that's going to give me negative 4 is going to be x plus 4 because it's opposite. If you have a factor, if you have an answer of x equals 0, what factor is going to give you that? Okay, so that's actually just going to be x. If you said x equal to 0, you get 0. So we're going to distribute this. X squared plus 4x. Okay, so that's what we have right now. Now we're going to do the same thing we did like we did in the other example. So we're going to try to find if there's an a value, so our leading coefficient. So we're going to set it up as y equals a times x squared plus 4x. Okay, so we're just using that. And then a is what we're going to solve for. So we're going to use this point, 110. So we're going to plug in 10 for y. A is going to stay A, and 1 is going to go in for x. So when I solve this, I get 10 equals A times 5, and I'm going to divide by 5. So now I have A equals 2. That means that I have a leading coefficient of 2. So now what I have to do is multiply that leading coefficient, so this 2, I have to multiply that times the function I had. So our final answer, f of x equals, we're going to distribute 2x squared plus 8x. And that's our final answer. Okay, so let's look at a chart. Okay, so when we're given a chart, we want to look for 3 things: the 2 x-intercepts and the y-intercept. So I'm going to focus on -7, 0, -3, 0, and 0, 21. Okay, the 2 blue ones, those are my x-intercepts, since y is 0. So this is the same thing as saying x equals -7, and this is the same thing as saying x equals -3. So this factor is going to be x plus 7. This factor is going to be x plus 3. So I'm going to FOIL those two together. X plus 7 and x plus 3. When I FOIL this, x squared plus 3x plus 7x, so I get 10x plus 21. We want our function to have the same y-intercept. And remember, your y-intercept is your c term. So here, c is 21. Here, c is 21. If they're the same, it means that the leading coefficient is just a 1. You don't have to do anything else. So our answer is going to be f of x equals x squared plus 10x plus 21. Okay, that's good the way it is. And if we look at this last example, same idea. We're going to focus on the x-intercepts and the y-intercept. So here's an x-intercept. Here's another x-intercept. And here is our y-intercept. So if -4 is an x-intercept, that's going to be x plus 4. If x equals 2 is an intercept, that's going to be x minus 2. I'm going to FOIL these together. So x squared minus 2x plus 4x, so plus 2x minus 8. So now that we have our function so far, we want to compare the c terms. Since c in this case is a -8, and it has to be a -4, we need to figure out what our leading coefficient has to be. So what do I need to multiply to -8 to make it into a -24? Okay, so that would be 3. So that means 3 is our leading coefficient. So we have a leading coefficient of 3. So we have to put 3 in front of our function, x squared plus 2x minus 8, and distribute. So our function is going to be 3x squared plus 6x minus 24. So now our y-intercepts are the same. We have -24, check, and -24, check.